Let's start. Last week I've been reviewing Xuehan's PR introducing Interruptible Future, and hopefully I will wrap up the review. And also I was discussing their PR created by Unknown to address to to repair the corrupted object when we are serving a client request targeting them. And I will back to the tracker ticket, which we need to restart the client request, which when serving them we have the PR, sorry, the PG being target experiencing some changes in the acting set. Per discussion with Sam, we should start them from scratch. I'm working on it, and that's it. Evan.
Hi. So I just I made some changes to the PR. I haven't updated, like I haven't pushed the changes actually yet, but I've made the changes according to our discussion. Careful. And now I'm just trying to build it. So obviously there are some compilation errors and I'm just resolving through them. And after I'll be done with that, we'll probably have to run the thrash test. I talked with Shuhan and it doesn't seem like there are any like unit tests to check the recovery.
Can we get a chance to discuss the unit test with Shuhan? Regard.
Yes, I sent him an email, and
Okay.
apparently there aren't any. We don't have any tests available for that at the moment, so we might just have to run the entire trash test. And yeah, so I've just been working on that, and another update that starting from tomorrow. So tomorrow I'm going to Canada, so I'll be in a different time zone for a while until mid-December.
Okay. I'm going to attend the stand-up while you are in Canada.
Yes, I'm still. It's all the same. I'm still like working and studying at the same schedule, just like different times. So I'll probably attend the meetings on Tuesday, I think.
It will be the morning in your time zone, I guess.
Yeah.
Cool.
And yeah, that's it.
Thank you, Evan. Kunmei.
I finished the unit test for the OMAP tree. The next step, I will clean up code, rebase, and provide PR for review. And when doing the OMAP tree test, I found a bug in the extend map tree, the same in the OMAP tree. So fix the bug and provide a replay test case, and also there is missing in the allocate extend by type for OMAP tree for extend tree node type. So I already provided the updated PR for extend map tree, and maybe next week after the clean up code and provide the OMAP tree PR. That's all. Another problem when I doing extend map tree testing, it's I add many very big mapping in the extend map tree, and I meet a problem. So I will send it all the backtrace to Sam. That is their B tree map heap overflow. Something happened. So I'm not sure what's the problem. Still thinking debug on it. So maybe ask Sam to help me take a look. Thank you.
You have a producer already, right?
Can produce when I add a very big number of extent mapping and remove one by one, and after remove about over 1,000, and it has a problem in the LB tree lookup range. They reported the heap is overflow, something like that. I'm not sure if it is my code issue or LB tree issue, but it's very big extend map tree insert because I want to trigger the internal node split and merge. So because the insert key and value is too small and the items interest is very big, so I need a very big insert and to trigger the internal node split and merge. Internal split merge is happened before the 1,000 remove key, but after the 1,000 remove key, and I meet some problem. I couldn't remove all the items, and there is a problem happened. But if I just remove 1,000, it is okay, and all the internal node merge and balanced and split happened before it.
Okay, gotcha.
So I will send out to Sam to help me take a look.
Sure, just include a detailed reproducer. A branch with a command to run.
Sure, no problem.
Hey, Sam?
Okay, so I decided the easiest way to write a good performance tester for different elements of SeaStor was to implement an NBD server with a backend that could talk to either the transaction manager or SeaStor once it's more complete. The problem is I wanted to create an FIO backend that could talk to something in SeaStor, but that turns out to be basically impossible because you'd have to write an inter-process queue. And fortunately for us, there's already a protocol that does that, which is the network block device. So I wrote a simple NBD server, like extremely simple, that just hands off the relevant IOs to transaction manager because, block offsets look a lot like LBAs. So it just hands off the same IOs straight down to the transaction manager in the new submit transaction. And I'm attempting to get that to work. I have the NBD portion working and most of the stuff wiring it up to transaction manager working. I am fixing bugs. Yingzhen, you asked me a question about concurrent transactions. That's one of the things I plan to iron out here because obviously to get good throughput, you want concurrent IOs. So I expect to shake out a very large number of bugs in that system with this. That is what I'm working on now. Secondarily, there have been some discussions regarding how to accommodate NVMe over Fabric in Rados going forward. So I've been gaming out some different strategies for changing the Rados protocol itself to permit clients to do more direct hardware-assisted I/O. I want to try to produce a design document in the next couple of months, but I want to get further in SeaStor before I devote a lot of time to it. That's it. Oh, go ahead.
Sorry, please go on.
I think Yingzhen talked.
Okay, I'm just confirm that you are using NBD server instead of FIO to test SeaStor, right?
I'm using FIO to talk to an NBD server. FIO has an NBD backend that'll just behave as a normal network block device client. That seemed like the easiest way to get FIO to talk to other stuff. Linking
FIO backend to talk to NBD server that is running SeaStor.
Exactly. Right. Okay. And then we'll just write multiple interface implementations as we get further along. Like I'll write one at the transaction manager layer, and then we'll write another one that talks to SeaStor itself. So the transaction manager one, of course, bypasses the ONode stuff, and then SeaStor as a whole would also test the extent manager, ONode, and OMAP. Right? So we can get a better sense for where the bottlenecks are.
Yeah.
Okay, so FIO is sending block writes, right? SeaStor, wait, hang on a sec, other direction. Okay, so there are two processes involved. IO. What do I call it? There are two processes. There's the FIO process, which is perfectly ordinary FIO, like you'd find in any modern Linux distribution. If you just give it a Unix domain socket and the NBD protocol, it just opens, a connection over that Unix domain socket and talks NBD over that to convey block commands to the other side. Which in this case is a fairly short handwritten server in SeaStor that just speaks the simplest version of the NBD protocol I could come up with. I downgraded it to the old server so I didn't have to worry about the options, whatever. It's very simple, not a lot to it. There's already an implementation for RPD in the Ceph tree, so it was partly a matter of translating that. Although I couldn't use the Linux layer, which is annoying, but whatever, because it's synchronous. It accepts commands over Unix domain socket, sends them to SeaStor, and then sends the response back when it's done. There's not a lot going on here.
That looks very clear. Thank you.
Yep. I mean, it's not the best thing in the world. NBD isn't a particularly cheap protocol. Like, it's kind of a CPU expensive, but for what I need today, it's fine. And it has the benefit of not requiring hacking FIO itself, which I've done before, and it's not easy.
Okay. But if I recall correctly, we do have a FIO backend for
Object store.
Okay.
Yeah,
yes,
we do.
For object store.
There are reasons why we don't want to use that approach. For one thing, if you've ever used it, it's a giant pain in the ass. It's really prone to crashing FIO because FIO's memory handling is kind of complicated internally. I spent like 3 weeks debugging this last year. It was really frustrating. But the big reason is that FIO and SeaStor cannot share an allocator, period. So I can't actually...
Hold on. It's probably not true anymore.
Okay, fine, but I'm not. I am extremely uninterested in playing that game, and it would still require 2 separate threads with a communication channel. It wouldn't necessarily be any faster. This is simpler. This is actually less work, and it has the benefit of not triggering all of those other ancillary build problems. This is just a perfectly ordinary Unix domain socket server. It doesn't need to, I don't need a custom version. We don't have to build a custom version of FIO to use it, for instance.
Yes, I agree that.
So this FIO only test the SeaStor, right? Not include the Crimson, the other layers.
Yeah, when we get further along, we don't need FIO we don't need anything special for FIO to talk to Crimson. FIO speaks RBD natively.
Okay.
Like, current distributions of FIO already include an RBD backend. That's not a problem. The purpose for this is that SeaStor isn't mature enough yet to run a whole OSD. And even if it was, I don't actually want to test the OSD. I don't care about that part right now. I just want to test the part I'm testing. The more code involved, the more difficult it is to discern differences in performance and design changes. Also, we can reproduce problems a lot more easily this way. This will crash, and I would really rather know where the crash is, I guess.
So Crimson Store NBD is just a very thin wrapper around the SeaStor to adapt to the FIO NBD backend. Okay.
Yeah, exactly. And it's got a little interface so that when SeaStor gets a little bit more mature, we can write a little backend for SeaStor too. That'll do the same thing. It'll just be into 4 megabyte objects or something with some token xadder write each time to simulate what the OSD would be doing. You see what I mean?
One more question. Is the Unix domain socket could be a bottleneck between FIO and the SeaStor?
Yes, it could be. It's not going to be any worse than TCP, I don't think, though. If it is, we can change that part. I don't really care. Is it slower than TCP for loopback?
Not sure. if it's not okay. I think it's to enforce the ordering. So if we want better bandwidth, probably we need to have multiple Unix domain sockets.
Well, it's not really using bandwidth. What it's doing with a Unix domain socket, it's using a little shared memory buffer inside the kernel and some shuffling back and forth. So we're a little memory bandwidth bound, but NBD itself is, in some senses, sequential. Let me put it this way. I don't plan on using this to prove that SeaStor is fast. For the moment, I plan on using it to prove that SeaStor works. And SeaStor, I kind of expect to be slow enough right now that this will show bottlenecks. Eventually, it'll stop showing bottlenecks and we'll have to get clever. But this is good enough for now. Also, if the serialization deserialization part is genuinely the problem over memory, then we're in a very good place, I think.
No, I'm not worrying about the serialization. I'm worrying about the ordering because it's like TCP/IP, a single channel TCP/IP. You need to ordering all the package along.
That's true.
Over the TCP.
There's no actual TCP here, though. It is indeed a single stream. That's true. But if we wanted parallelism, we would just run multiple SeaStor backends and multiple FIOs, that's what these workloads will look like in general anyway. So in other words, yes, we'd use more than one socket, but we'd also use more than one thread.
Okay, probably we can worry about it later because what you're focused on is the functionality test instead of performance test.
Well, I do also expect it to be a performance test once it works. Like, I expect there to be enough problems with the current SeaStor that this will show bottlenecks. When that stops being true, we'll do something smarter.
Okay.
Like, keep in mind, the entire garbage collection process has to happen in line with these writes. Like, its current SeaStor is pretty heavy. We're going to have to do some work. That is, every byte we write needs to have a byte garbage collected from one of the occupied segments. The odds that I did that optimally the first time are not high.
Understand. And regarding to the NVMe over fabric, I'm just wondering if it's like inform the client which endpoint would be talked to in the protocol.
This isn't really about NVMe over Fabric. It's about changing the protocol so that clients can do writes without coordination. It would be a bigger project than Crimson. It would be twice as big as Crimson, I think.
I'm wondering it's also related to how we shape the M2N, because
not really. I wouldn't worry about that. Yep. So bluntly, the biggest and best version of this would never see the Crimson code. What Crimson would do is it would set up conditions that make this work, and then NVMe over Fabric would handle the actual I/O. That I/O would never see a CPU. That's the goal. So this isn't really a Crimson efficiency thing. This is a protocol level thing to enable some kind of full bypass from the client all the way through to the device. I don't know what it would look like yet.
But I do imagine that it could be related to the M2M mapping.
No, I'm saying that the fast path here wouldn't wake the CPU at all.
Yes, I know that NVMe over Fabric might not. The goal is not to involve the CPU and bypass the CPU and the kernel probably. But I think regarding M2N, I think the part of the goal is to allow the client to talk to a core, for example, or a shard. But to inform the client to talk to that shard, we need to have a fine-grained.
No, all we need is an extra small bit of information in the existing OSD map. That's like a tiny, tiny change to Rados. That's current Rados with a little bit of extra information in the OSD map. That's not really what I'm talking about here. So right now, when we do a write, we write a PG log entry. Right?
Yes.
So what if we didn't do that?
I think we are probably. I failed to clear myself. My point is that one problem we were discussing regarding to M2N is that the client, the messenger cannot be shared
Yeah, that's
between
true.
cores. So
I know.
one of the solutions is that we have a multiple, we expose multiple ports for multiple PGs, and we shard PGs by ports.
Yep.
To make this happen, we need to inform the client which port is exposed, the mapping between the ports and the PGs.
Uh-huh.
So I think it's quite close to what we want to have. I'm not quite sure what you imagine regarding
No. So that's
fabric,
not.
but I think they share quite the same problem because
they don't. This isn't about exposing things to the client. This is about doing a write without updating metadata, and to allow many clients to be updating objects in the same OSD without coordinating with the OSD or each other. This wouldn't look much like current Rados. It would be pretty radically different. For instance, it may not be the case that you even talk. Right now, for instance, we do primary replication. Client talks to primary talks to replicas talk to the primary talks to the client. Imagine if the client did an NVMe over Fabric operation directly on an exposed device with no intermediate coordination. No OSD CPU wakes up, no one processes a message. There's no log entry, and there's no metadata written. That's what I'm talking about. It's not really about our current message protocols. It's about not using them at all. In other words, there would be control messages that happen in the OSD, but for block device operations, hypothetically, if we could make this work, then we simply wouldn't wake up the Crimson OSD process at all. There would be no message queue, there would be no thread handoff, there would be no thread. It would go from the original device to some kind of a smart NIC, do a smart NIC on the OSD to the PCI Express device without ever waking a CPU.
Like client just write directly to the remote disk.
All three of them, yeah.
NVMe.
So the question is, what would we have to do to the way we do, like under what conditions would that be possible? And how would we maintain an appropriate level of consistency and atomicity guarantees to clients? What would that look like? What do we have to do to the Rados protocols to make that work? What does peering look like if clients are allowed to do that? How much work do we have to do when an interval changes? Bring things back to consistency, that kind of thing. This isn't really about ports. It depends a lot. Like that's what we're looking at.
Okay, probably the M2M parts is a very
different.
More problem. But I think
we could definitely
to make that happen, we need to inform the client which the NVMe, the remote entry point is that should be exposed to the client, so the client know which the mapping between the objects and the.
So here's why it's different. Here's why it's different. There's a really simple way to do what we're the M2M thing right now, today, with current OSD maps. Right now in the OSD map, there's a mapping from OSD number to port and address, right?
Yeah.
It's literally there. There are 4 of them, I think. 2 public IPs and 2 private, or 4. Some number of heartbeat ones that I can't remember the number of, 1 public one, and some number of cluster ones for replication. And they're all just listed in the OSD map. Everyone who has the same OSD map agrees on the same IP port combos.
Yeah.
So what we do here is we'd say, instead of saying clients talk to OSD 81 on IP whatever, port whatever, we say, okay, these 10 ports are assigned to this OSD, and you simply take your PG, mod the port number to get the port you talk to.
Yeah, or set up a policy, for example.
That's what I mean by policy. It could be that, or it could be something more complicated. But the important part is that clients don't actually need any dynamic information about the OSD to get this right. It's published in the OSD map, and that's just what it is until the next interval. By contrast, with the NVMe over Fabric stuff, you can't just say, this is the device you're talking to, because the dynamic location of an object on a device is not something you can predict in advance. At least not easily. That would be, there might be ways to do that, but it would give up properties of Rados we like. So we probably wouldn't do that. It would be more like there's a higher level communication channel that communicates rules about where certain contiguous regions of certain objects are, if they're frequently enough accessed. And then you could map those directly to clients over this thing Intel was presenting on a couple of weeks ago. It's just...
Use NVMe also.
I'm sorry?
They commute this message over NVMe also.
Their approach it actually does, but that's not... The Rados side still needs to happen because we do need to maintain enough metadata. to allow us to complete peering in a timely fashion. So it's nothing about this is really about NVMe over Fabric. It's more about taking the protocol that NVMe over Fabric is and figuring out whether we can make a protocol like that work without coordination. In summary, this really has little to do with M versus N, or M10. I really wouldn't think about them at the same time.
Okay.
Things that come into this message queue will look pretty much like what they look like now. There will be an operation that needs primary coordination on a PG, and there will be some kind of a mapping. A PG will handle it. It will do some kind of atomic transaction, and then it'll be over. The NVMe over Fabric stuff will be really, really different. Or only somewhat different. It's hard to say.
So what is the major advantage to switch to NVMe over Fabric protocol?
You'd be able to run a full throughput PCI Express device on ARM hardware. That's what. Because the CPU wouldn't be woken up for every I/O. Or like a modest but beefy Intel chip could drive an entire gigantic high-density NVMe device. It's the same thing Crimson is about, just more so. And this is not something we started talking about yet. This is just a thing Greg and I and some of us got talking about after the ADNN presentation at CDM a couple of weeks ago. I just want to flesh out a design document in the next couple of months. This is not like a plan yet. Does that make sense, Yingzhen? The idea is that if you could somehow drastically reduce the number of situations where an OSD needs to be involved in an I/O, then the CPU cost for those I/Os goes from a lot to virtually nothing. And even Crimson, even if we did Crimson, if we implemented Crimson with the best efficiency we possibly could, it's still the case that at least a few clock cycles have to happen per I/O.
Yeah.
Which is more than 0. 0 would be better than a few. Anyhow, that's what I'm thinking about. Mostly though I'm working on SeaStor.
Sam, can you link the talk you are referring to that you said that you started discussing after?
Crap, hang on. Ceph Developer Monthly. If you Google it, they're YouTube. Is this it? There might not be a video this time. It might not have been recorded. Yeah, this one didn't get recorded. I'm sorry. The notes from it are here. The design that Intel was presenting was the question was, how do you use a bare metal host to access an RBD device? So the obvious answer is you run NVMe over Fabric on the host and attach it to a software. Oh, found it. Sweet. It's not linked from the wiki.
Okay, thank you.
Wiki. But other people will be able to find it. Anyway, the idea is that you use NVMe over Fabric to talk to a software terminating thing on a gateway host, and then that gateway host speaks RBD back to the cluster, right? So easy peasy, simple, but kind of crappy because you have to do the second hop over Fabric. So their design was you embed a bunch of information about where each block of an RBD image is located. Basically by giving it the little bit of math required to map the object name to a PG, and then giving it a lookup table from the PG back to the OSD numbers. And then have it talk directly to one of these NVMe over Fabric terminators on the OSD, which then speaks RBD right back to the locally hosted primary. So you will avoid the second hop. But if you think about generalizing this, and I talked about this a bit in the thing, in the question part after, you can eliminate the scalability problem by constricting where objects are allowed to map. So the natural question after that is, if you're speaking NVMe over Fabric directly to an OSD because you've eliminated the intermediate part where there's an RBD image, or where you're speaking, librd, then how do you start cutting down the metadata overhead of conventional RAIDs? So it's an interesting opportunity to optimize for these higher random IOP workloads. I don't know if anything is going to come of this, and it's a genuinely difficult problem space, but it's worth thinking about.
So it won't support RGW, right?
No, and it won't support SFFS either because the protocol will be inherently weaker. So Rados the problem essentially is that Rados is really good at what it does, but it offers guarantees that RBD doesn't need. Like, block devices don't actually offer ordering guarantees. They just don't. Like, they don't even necessarily offer read after write. That depends. Because caching on the client will typically handle that. They don't offer like guaranteed order delivery of operations. So if you send a prefix of operations and then get a path failure and then resend the same prefix, you might actually get a different outcome from what you got the first time, depending on details of which portions of your write got through the first time. And if there are parallel writes to the same object, really all bets are off. It's very complicated, the outcomes that are possible. For these reasons, the network protocols associated with block devices are typically much simpler than Rados's, and they offer far fewer guarantees, and as a result, they're typically faster. Kifu, you were alluding to this earlier when you mentioned that using a single stream is less efficient than using parallel streams. That's a correct observation, and it's why block device protocols are usually designed the way they are. It's so that you can exploit parallel streams across a network or fiber channel or whatever. So for things like Rados GW or Ceph's metadata operations, Rados is awesome because it would be very, very expensive to implement this kind of atomicity without help from the cluster. So in reality, we would want both. We would want to be able to use the strong guarantee protocol when we want it, like for instance in RGW when we use the conditional writes to ensure that we get atomic writes for objects, and be able to degrade to weaker guarantees when that's what we really want. For instance, for RBD or perhaps even for some CephFS files, though that is less clear to me. So we would want to design it in such a way that the protocol is general enough to be adapted into CephFS and maybe even RGW for some of its writes. It's not totally clear to me. But efficient enough that RBD is able to operate well, or is able to operate it close to what we think is the best that is practical given the design constraints and hardware realities of life. Like, for instance, if one design constraint I think is very unlikely to go anywhere is that we offer consistency, and that as long as you have 1 out of 3 remaining replicas, you may continue doing reads and writes without noticing any anomalies. That guarantee alone is something that many storage systems don't offer, but it's one that we will likely want to continue offering, as it is important. So it's not really about weakening the guarantees RBD offers, it's about not offering guarantees it doesn't need. And hopefully that gives us enough freedom to perhaps, under some hardware configurations, maybe at least design out what a direct client-to-disk protocol would look like. Maybe. Anyway, I'm excited because the NVMe over Fabric thing finally seems to be a general enough industry solution that we could use it without being locked into a single vendor. So I'm excited. Maybe. A lot of the previous hardware offload stuff has been a little bit more vendor specific and thus a little bit less attractive for investment.
Yes, also it reminded me a discussion with on the RDMA solution.
Well, this would be in many ways RDMA, right? One thing, Yingzhen, this is not a thing the Crimson Project is committing to. It's not even a thing Red Hat is committing to. This is just a thing I've been looking into the last 2 weeks. This could just go away if it turns out that it's impractical. Just so you know, for communicating with management.
Thanks for sharing, Ken.
But if you happen to know Scott Peterson's information, that I really like to stock.
Go ahead.
last week I was on major testing and fixing Crimson recovery related bugs, and this is the branch I'm working on. I fixed those bugs based on the interruptible future branch, and I think once the test goes well, and I will submit all the commits into the interruptible future PR. And, that's all.
Xuehan, in last stand-up, you mentioned that you have some fix which does not depend on the interruptible future, but I fail to see them.
Yeah. I implemented those fix on the interruptible future branch,
Okay.
and it seems there's some extra work needs to be done. That needs to be done if I need to separate them into another branch, and since I think both the interruptible future commits and those bug fix commits all for the purpose of a smooth running of recovery, and I think maybe they should be submit together.
Okay.
I think
because I'm still reviewing your interruptible future because it could be controversial regarding to the granularity, because I kind of agree with Sam and the concerns raised by Sam and Redek, because they believe that there is a chance that there could be some other PGs which not relate to exist one to sneak into the interrupted continuation. So.
Wait, is there still a bug? I thought we found we thought of a way around that last time. It was just the with
interrupted continuation, right?
That should prove that it's impossible, I think.
Okay.
I mean, that and the asserts, although I need to read it carefully, of course. But again, you should satisfy yourself with that. I could easily be wrong. This kind of code is really, really tough.
Yeah.
But that was my thought at the time, at least. And there are asserts, right? So that if something like that did happen, we would notice.
Yeah,
immediately.
there are asserts.
Coolio.
Okay. Anyway, so I thought it would be easier if we could split them up into two different PRs. If it's difficult, probably we need to review them all together. Anyhow, I'm still reviewing it for information. That's it.
Yeah.
That's sorry. It. Okay, Yingxin.
Most of the time last week, I went to SeaStor implementations and sent out some questions to Sam and Kofi today. And I think I may send out some related fix later. And another thing is I may need to arrange some efforts on persistent memory or Optin SSD to prove their values with Crimson. So I'm trying to look for a simplest and direct way to make use of them in SeaStor in order to get some initial performance results. And maybe I will use 50% of my time to do that.
So you need to scratch some preliminary implementation for example, to persist the index into Optime.
Maybe persist the cache in Optime, so we don't need to rewrite them. So it may save some effort, and it will be reflected in.
Oh, sorry. Go ahead.
In some benchmark.
So it's more than design. It will be a workable proof of concepts.
Yeah.
Okay.
Sam?
Sorry, I missed a bit. Were you saying you were working on a way of running the cache on top of Optane?
Yeah, this might be one way to do that.
Okay. I have a suggestion that you may want to do first. I suspect that one of the most common use cases for Optane, at least early, will be for caching metadata and the journal. So I would be interested in an interface system and implementation that first moves the journal into Optane and then moves the LBA manager.
Okay, so yeah, so LBA and journal running on Optane memory, right?
Unless you think that the B-tree implementation in... Yeah, it doesn't seem appropriate, though. I'm not sure. You might want to put together a bit of a document, and then we can talk about it.
Yeah, I will.
I can think of a lot of ways to do this. There's a lot of design to talk about.
Yeah, a lot of different ways to do that. And,
yeah, I'm excited about this. It'll be good to do that. I think we're at a place where that will be a good thing to do.
Yeah.
It makes sure we don't go too far down the SeaStor implementation without thinking about persistent memory.
You mentioned that you sent some question to me and to Sam. Did you?
Yeah.
Did you send it over email
or an email?
Or... Huh? Okay, it's email. Okay.
It's email. Yeah, it's email.
Cool. Anything else?
No.
Did we want to talk about the M2N thing? Although it's a bit late / whatever time it is, different places. We could do it next week too.
Yes, I'd like to talk about it if it's fine by you or any other guys.
Yeah, it's fine by me. I've got a good 20 minutes.
So I believe that it's a way to short the PG by ports. That's it, and do the preliminary design changes to embed this information in the embedded this information in OSD map.
I have a different opinion.
Sure.
I think that's where we're going. That's the end state, for sure. But we should consider the following things. Depending on exactly how the mapping change works, it's almost certainly the case that we have to tolerate connections on the wrong core. In other words, I don't think we can just assume that all connections will come in on the right core. It will be the case occasionally that we need to forward a message to the core that is actually responsible for it.
Agreed. There's some happy paths and
yes, but
not
for now,
happy paths.
Because we have to write that code, and because for now I actually care less about performance than I do about the fact that we definitely made mistakes when we wrote the current, like the current version of Crimson definitely makes some assumptions about single core behavior that are probably not true. I think we should skip the Rados protocol part for now and just go ahead and run it on multiple cores with either one messenger forwarding messages to all of the cores or n of them, and they all listen on the same port with randomly balanced connections across them. And then just go ahead and implement a crossbar. Which again, we have to do anyway for correctness. It's mandatory.
To be clear, it's not a round robin or random. It's a sharding algorithm implemented by SeaStor.
Okay, yeah, that's fine. What I mean is a single client talks to a single core, or a single TCP connection talks to a single core, and that core forwards it on to whichever PG needs it.
So which implies that whenever we do talk to the client, we always pass this continuation to, or this action to this task to that core where the connection is established.
2 core handoffs, right? One from the originator to the handler, the other back for the reply. It's ugly, but I think it's okay for now. And the advantage to this is that we can get topology coverage on multi-core Crimson before we get the Rados protocol changes done, which will be much harder. And once we have the Rados protocol changes, nothing changes in the Crimson code. It just means that this handoff mostly doesn't happen.
In most cases, happy cases, yes.
But it's one case. You hand off. There are either two handoffs or there are zero handoffs. There is never one handoff. They're the same thing. Either the message and connection went to the right core or went to the wrong core.
Right. Agreed.
Right. And I'm saying that once we have the smarts and Rados to have clients initiate multiple connections based on where the I/O needs to go, this will simply stop happening. It'll always go to, or it'll usually or always go to the right core. And because the other reason I want to put this off is that changing the Rados protocol is much, much more difficult than changing Crimson. The design outline before with the thing where you just like take the thing, mod the number of PGs, actually kind of sucks because it means we have a static assignment for every interval of PGs to core, which might not be what we want to do. We might want to actually change the messenger v2 protocol itself to embed some information that says, actually, Mr. Client, if it would be all right with you, please initiate any further operations on PGX to this other address, please.
In other words, we might want to embed such the information regarding to the mapping of PG into
the messenger protocol itself and let it be dynamic. And the advantage to that is it lets us dynamically move PG handling around cores, depending on hotspots. So there's a lot of design work to be done here, and that's why I don't want to do it now. The part I want to do now is get Crimson capable of running on multiple cores. We can do the optimization.
We need to do
this.
Yeah.
The optimization can wait, and it doesn't really impact the way Crimson itself works. That's why I kind of want to put it off. It only impacts the upper immediate handling layer. And again, because we need to support old clients, this code needs to exist anyway.
Yeah,
we
backward
could try it out.
compatibility, right?
Yep.
Compatibility sooner or later.
Well, and we can definitely start, in parallel, we can write a design document about what we want to do to either the messenger or the OSD map protocol to figure out what we want to do to change this. That's the other half. We can totally do that in parallel, but I don't want to block it. I think the more immediately important part is getting test coverage on multi-core Crimson. Because once we're sure that works, we kind of just need to change the protocol. It won't really cause bugs. The risky part is making sure that we have thread local variables everywhere we need them. We haven't made any assumptions about memory allocation. Like all that stuff's tricky, especially with BlueStor, and it's very likely that we mess some of it up. So the sooner we shake those bugs out, the more confident we'll all feel, I think.
Yes, I'm all for it. And I think
and
it's also
parallel.
required that we need to better coverage of the Crimson in our testology-based test.
Yeah, but that's always true. Like we always want to increase test coverage. So
by the way, the change to collocate the default allocator with the SeaStor allocator has been merged to SeaStor. So I will bump up SeaStor to some module to include that change to enable us to run the SeaStor and libc allocator in our Crimson the testology based test. That's for information. Okay, I will add the some of the text to our Trello so we can work on it later on.
Oh, and for the partitioning part, there's also a SeaStor component, which is do we want PGs to be able to move dynamically between SeaStor shards? Sorry, I just wanted to bring that up. We will have to think about that too.
Great, yes. That's also related to the M2N.
Yes, it's definitely part of M2N. Yep.
Anything else?
I had the last part.
So everything that I've written so far in SeaStor assumes like a single journal thread and like a single consistent metadata tree, right?
Yeah.
But the scaling on that would be terrible.
Mm-hmm.
Every time you try to mutate the root block, it's going to conflict with every other operation. So the reason why I'm not worried about this is that I anticipate that on 4 cores, there will be either 4 or 2 or 1 SeaStor instances. And those instances will have separate metadata structures. Also, Keith, this is the other reason I wanted to make sure we had the ability to do cross-core operations. It's that for an 128-core machine, I really don't think we're going to run 128 SeaStor instances. I think we'll probably run 16 with groups of PG threads mapped to them. We'll run whatever is the correct number to maximize throughput to the NVMe device, but not more. So that will require a core handoff. And we probably won't even run PG code on those cores. It'll just be SeaStor. So that's the other reason to go ahead and write the version without optimizations, because there will be situations where that's appropriate. I think.
Okay. Yeah.
Probably worth writing some of this down. Do you want to write like a document on what we think we're going to do with M2N, or do you want me to start it? Or we already had one, didn't we?
I have a write-up in the pad to.
Oh yes, all right, that works.
Let me find it.
Is it in the invite? Yeah, there we are.
Post it in the chat window. Oh, okay, you already found it.
The pad's kind of good because we don't even have to like invite people to it; they can just read it. Yeah, fair enough.
Once we itemize these working items, we can add the items to the Trello. So we don't forget them. And I will try to enable to tweak the test to enable the multiple core deployment, so we can test it to see what happens, and add whatever pop up as a tracker ticket or a Trello ticket. Anything else? Nope. Okay, talk to you later, and have a good one. Thank you.
Bye, everybody. Thank you.
See you.
Yeah.